Hi, hello students. Welcome back to India's most comprehensive online learning platform, BYJU'S Exam Prep. This is Aneel Prasad Sir, and in this session, we are going to discuss about the solutions for critical section problem. Yesterday, we comprehensively discussed what is critical section problem. We understood what are the origins from where exactly we're going to have this problem. Being an application program developer, you may develop a lot of applications in which you may have a lot of cooperative processes. When these cooperative processes, when they want to use a shared memory region, they need to execute a specific section of code. When they are getting into that code, they need to check that they are the only processes entering into the critical section. That means that at a time, only one process is allowed to enter into its critical section. As simple as that. So in order to make sure that only one process enters into its critical section, we need to analyze various solutions, and all the solutions need to satisfy several criterions such as mutual exclusion, bounded weighting, and progress. This is what we have discussed yesterday. Just to have a simple recap, I discussed that. Now let us start today's session with the probable solution, the possible solutions that we can use to protect our critical sections every time when we develop an application. So let us start. Please like, share, and subscribe to this channel if you haven't already yet. Just make the people potentially use these free sessions, and you guys also who are watching, just follow the class very carefully. Once again, before I take you people to any of the solutions, my urge and request is pretty simple. You just have a scribble pad, and every time when you find a point is important, just scribble that. Otherwise, you don't need to anything. Other than that, you don't need to do anything rather than simply listening to myself. So let us get into the world of the critical section and the solutions. So let me skip this. You already knew. This is my Telegram channel. Most of you people are requesting to provide my Telegram channel. This is my Telegram channel, and you can follow me. And you can join in this to get the updates, and if you do have any doubts also, you can shoot in the same channel. I will be able to reply you guys in this channel. Now, only 8 months to go for the GATE exam. I want you people to capitalize these 8 months productively with BYJU'S Exam Prep. So let us start this session without any delay whatsoever. So hi Anu, hi Chanchal, hi Krishna. Hi Chitra, very good evening. So shall we start? Shall we start? Okay then. Now, to start with the critical section problem, yesterday we discussed about a few solutions. I just want to change the pen color. Just give me 2 minutes. Yeah, let us understand. In the previous session, to have any solution, to design any solution, or to follow any solution to provide the to protect the critical section, I require any kind of locks or any premises, but any solution what you follow need to satisfy 3 criteria such as bounded weighting, mutual exclusion, and third one is progress, right? Now also understand, when you develop and design a solution to protect the critical section, you also must be able to understand in which kind of a kernel you are going to run your application. Let us understand, whenever an operating system is developed, the operating system kernel can be any of these 2 types. One is preemptive kernel and one more is non-preemptive kernel. What is a preemptive kernel? Simple. I don't need to explain or talk much about the preemptive or non-preemptive kernels. You know that every time when a program executes, that program will execute in 2 different modes. One is user mode and one more is kernel mode. When a program enters into the kernel mode, it means that it is utilizing a service that is being provided by the kernel. Alright? So understand, in this light, we need to discuss about the preemptive kernel and a non-preemptive kernel. When a program is in the kernel mode, that can be preempted in a preemptive kernel. But when a program is executing the kernel mode, that cannot be preempted in a non-preemptive kernel. Sir, why we need to understand? What is the big deal with the preemptive kernels or non-preemptive kernels? Understand carefully. By using a simple example, I will explain why this makes a lot of difference. Why it does matter to discuss at this point of period. For an instance, let us say there is a program 1, or else I will Anu, okay, or Chitra. Let us say there is a program Chitra.c. When this Chitra.c is executing, let us say this program wants to access a file. This program, when executing, it opens a file. That file name, let us say file.1, rather file1. When this program is executing, when this process is executing, it accesses a file. It opens a file. So similarly, any time when a new process, rather when a process opens a file in the entire computer system, immediately what is going to happen within the kernel, let us understand. There is a list, there is a data structure which is called file list. I will write it here. File list will be updated. Once again, anytime, every time when a process opens a file, immediately the mode will be switched to the kernel mode and the file list will get updated. This file list is the total number of files opened by several processes in the system. Currently, the total file list is equal to 20. That means that 20 files are opened. When this Chitra.c opened one more file, immediately within the kernel mode, it has to be updated. Understand, this file list is a kernel data structure. It has to be maintained within the kernel. So, it will be updated to 21. Now you can simply understand. Let us say two processes open two different files at the same time. What if two processes update the file list at the same time? There will be chaos again. This file list might not be updated correctly, rather it will be updated inconsistently. Same problem as we have seen yesterday, which is pretty much similar to counter variable. Both processes can read the file list at the same time as equal to 20. They try to update the file list to 21. Now when two files are open, obviously the file list must be equal to 22. When both processes can be able to enter into the kernel mode, they may access the same data structure which is file list and can read the previous value of the file list and they can update to 21 rather to 22. So same problem as we have seen in the previous session can still be persisting if a process is allowed to be preempted from the kernel mode. So in order to avoid that, what we do is, some perspective is, we can follow an approach of non-preemptive kernels. In a non-preemptive kernels, obviously, a process which is executing in the kernel mode can never get preempted. For instance, in this case, Chitra, when it opens a file, immediately this, the process Chitra, she has to enter into the kernel mode and update this file list. As long as this program is in this kernel mode, can never be preempted. This program can never be preempted. So, non-preemptive kernels are essentially free from the race condition. But the preemptive kernels, we can't give the same guarantee. The thing what I have stated can still be on the cards, right? So, the thing is, my question is, when you design a kernel, what would you choose? Preemptive kernel or non-preemptive kernel? Obviously, you may say that, sir, non-preemptive kernel. When I become a kernel developer, I would choose non-preemptive kernel. Simply wrong. Non-preemptive kernels are less responsive than preemptive kernels. When you talk about a non-preemptive kernel, let me tell you, the biggest disadvantage with the non-preemptive kernel. One process enters into the kernel mode and it is executing too many services. The process is not leaving the kernel at all. If the process doesn't come back to the user mode, the process cannot be preempted at all. In the non-preemptive kernel, when a process enters into the kernel mode, this process can never be interrupted or preempted. So any arbitrary process, any random process during the execution may enter into the kernel mode and can execute for too much time in the kernel mode, can spend for too much time in the kernel mode, before which it cannot be preempted at all. Until and unless it relinquishes the kernel, it cannot be preempted at all. So the non-preemptive kernels understand that these are less responsive. Preemptive kernels are more responsive. Now understand why we have discussed this. Our solutions should be designed keeping the aspect in the mind that most of the operating system, 99.99% of the operating systems follows the approach of the preemptive kernels only. Now let us get into the solutions of the critical section problem. Okay, so now I will tell you a simple way. I don't take all these things. I will tell you a simple way. I will admit a simple way to protect the critical section. Are you with me? Are you just listening? Say yes, Chanchal, whoever, sitting before the system, just talk to me. I'm just going to admit one important solution, a wonderful solution. I don't need any locks. I don't need any solution at all. By using a simple approach, simply I will resolve the critical section problem. Can I? Yeah. Stay focused. Let us see. This is my CPU. Okay. This is my CPU. And currently, one process, myself, process ANI, executing within the CPU. In the main memory, there are other cooperative processes, PCHI and PANU, PANCH. These guys, in addition to myself, also the cooperative processes. They also want to enter into the critical section. Now the thing is, when PNANI is executing, he is executing in the critical section. Okay, I would point this way. Yeah, he is executing in the critical section of code. Let us say my critical section of code is in between 20th instruction to 30th instruction. Within me, if I execute, in between 20th to 30th, I'm executing in the critical section. So let us understand something. I finished till 23rd instruction. That means that I'm not yet finished with my critical section at all. But the problem is, due to the concurrency, let us recall again, the biggest problems for the operating system is concurrency and the preemption. Due to the concurrency, in order to achieve better throughput, this process may get preempted, right? I won't be allowed to execute completely. I will only be allowed to execute for a stipulated time. Did I make it myself clear? I do have 100 lines of code. Will I be entitled? Will I be allowed to execute the total of my code? No. Only for a stipulated time, I will be able to get executed within the CPU. Let us say by executing right after execution of this 23rd instruction, the time that's been allotted to me to spend within the CPU has been finished. My time is over. I need to, leave the CPU. There will be a timer. Immediately, this is my timer. Immediately, every process finishes with its timeline. This timer is going to interrupt and says that your time is over, please get out. There are several other processes which want to enter into the CPU. I need to make the way to those processes. So let us say at the 23rd clock cycle, I got the interrupt from the timer. Maybe not only the timer, there comes one more process which has got more priority than myself. Making sense? So I can be preempted by n number of causes, but when I got preempted, I need to leave the system. But what happens at this point is, unfortunately or fortunately, I'm in the mid of my critical section. When I leave my critical section and I got preempted, there may be one more process, which is PANU, can make its way to the CPU. Got me? Now, Mr. PANI has got preempted. He has to be sent back to the main memory. Now, PANU entered into the system. Now, this process wants to execute within its critical section. Now you can understand where exactly the problem has been originated. The origin of the critical section problem is preemption. The origin of the critical section problem is interrupt. Making sense? I hope it makes every sense. Yes or no? Got my point? So here the thing is, I want to address the exact origin. I don't want to go for locks. I don't want to go for semaphores. I don't want to go for monitors. I exactly want to address the actual problem from where the total, the problem is building up. The problem is interrupt itself. If I get interrupted, that is a problem. If I'm allowed, if there is no interrupt, I will be able to continue with my critical section. Yes or no? Are you participate? I hope it makes every sense, right? Chanchal, what you people are doing? Listening or not? Sleeping? Anu, Chitra, are you there? Where is Abby de Villiers today? He went to sleep or what? Okay. Anu, you there? Please respond. Make the class interactive. I'm not here to teach, just to, walls. Very good evening, Sachinanda sir. Okay, now let me address the very problem. From where the problem has been originated, the problem has been originated at the interrupts. I need to talk to the system's interrupts directly. I don't want to use any solution. So what I will do is, okay, whenever a process enters into the critical section, I will disable the interrupts. System's interrupts will totally be disabled. That means that, let us say, myself again, process ANI is executing. Now he is in his critical section. When he is in the critical section, immediately the total system interrupts will get disabled. Sir, how to disable the interrupts? You can tell, you can say hell lot of things. You're talking about too much, pretty much complicated things. It is not a complicated at all. It is not a complicated, the topic at all. Disabling the interrupts is as simple as chewing a gum. I will tell you how to simply disable the interrupts. I will tell you. You write a C program. I'm not talking about a systems program. You write a C program, right? Okay. Now let us understand. When the C program gets converted to the machine language instructions, of course, any program, when it wants I/O devices support, interrupts are enabled. Sometimes, let us say, there are some applications such as scan doesn't require any I/O devices support. For an instance, understand something. I will tell you in which application interrupts doesn't work. Let us say system scan is running. Some serious system scan is running, no matter whatever you do. Either you move the mouse or you make a key depression on the keyboard, it doesn't work. So interrupt disable is a simple concept. What you can do is, being a programmer, simply by using two instructions, you can either disable the interrupts or can enable the interrupts. How to disable the interrupts? I will tell you. There are two instructions. The possible instructions are, for instance, one instruction called, ION. This is an instruction, which is the machine language instruction. When this instruction gets executed, interrupts will be switched on. There is one more additional instruction which is called IOF. That means that interrupts will be switched off. As simple as this. Only the thing is, you should be able to know how to use this instruction in your program. It is simple. It's not a big deal. But I don't want to go into the details. But simple. You need to execute these two instructions whenever either you want to switch on the instructions or switch off the instructions. Sorry, switch on the interrupts or switch off the interrupts. So what you need to do is, what is your critical section? Your critical section is in between 20 to 30. So before the 20th instruction, you write IOF instruction. Interrupts will be simply disabled. Okay. Right after the 30th instruction, you will execute ION. That means that interrupts will get enabled again. You can get preempted after the 30th instruction. There is no problem. Only the problem is, if a process gets preempted within this, the critical section, then there is a chance that one more process, which is a cooperative process, can enter into the CPU and start the execution of its critical section. So this way, I will completely be able to avoid the mess. Critical section can only be accessed by one process at a time if I can simply disable the interrupts. The solution is this simple. So far, did you get every point? Since we need to talk a lot of things. Yes or no? You got it or not? Okay. Now this is how we'll be able to deal with the critical section problem. But let me tell you, disabling the interrupts is not advisable. Let me put it this way, disabling the interrupts is not advisable at all. That too, it works only a single processor system. If it is in a multi-processor system, this concept doesn't work. The thing is, if you want to disable the interrupts in a multi-processor system, in each and every processor, you should be able to disable the interrupts. For an instance, there are several processors connected to the single computer. Single computer, in other words, having several processors. Each and every processor, of course, primarily it's a processor, it is independent, although it is connected to the other processors. Interrupt is an exclusive concept of a processor. Let us say there is a process PANI. When it is executing in this processor, and if it wants to disable the interrupts, it needs to disable in each and every processor. For that, a message has to be passed to all the processors in the system. Let us say there are 100 processors. Initially, in the current processor where PNI is executing, interrupts will get disabled. Right after which, a message will be passed to the next processor, next processor. Understand? Message passing, meaning in order to transfer this message to disable the interrupts, will consume a lot of time. This time consumption, of course, will be huge. Meanwhile, one more process can enter into some more processor. So it doesn't work in a multi-process. Simple. At this point, I want you people to understand, disabling the interrupts can only work in a single processor system, but not in a multi-processor system. But we don't know in which system our application is going to run. Our application, which has cooperative process, can run either in a single processor system or in a multi-processor system. So I don't want to follow disabling the interrupts approach in order to protect my critical section. Did I make it myself clear? Yes or no? Yeah, delay in sending the message makes this disabling the interrupt concept inappropriate and inefficient in a multi-processor system. So what are the other solutions? Many systems provide hardware support for implementing the critical section. All the solutions actually based on the premise of locks. Protect the critical regions via locks. In the uniprocessor, if it is a single processor, obviously you could disable the interrupts. But in a multi-processor system, it doesn't work at all. Okay. Now modern machines provide special atomic hardware instructions. Already I have explained you about one test and set lock, okay, to protect the critical section. This test and set lock has been provided by the hardware designers. I hope you went through my test and set lock session, right? Anyhow, I'm going to give a small recap on the test and set lock also before I analyze several other solutions. But before that, did you people go through the test and set lock session? Itra, Krishna, Anu, Chanchal. Okay, fine. Let us understand. In order to protect the critical section, disabling the interrupts, of course, it yields a better result, but only on single processor system. Okay. Now what we do is, we will analyze several solutions to protect the critical section. The first few solutions I'm going to take from the hardware developers. I'm a hardware designer. Rather, one of you guys are the hardware designers, and I'm application program developer. In my application, there are several processes, cooperative processes. Each of the cooperative process has a critical section. I need to protect the critical section. So when looking at my problem, being a CPU developer, let us say Chitra has come up with one solution. She told me, I'm a hardware developer. What you do is, I will give you a lock. Please protect your critical section with my lock. So I'll be more happy, since if a solution is being provided by the hardware developer, I'll be very happy indeed, because hardware developer, if he designs a lock, that lock will be atomic. Atomic meaning, understand carefully, only one process will be able to use the lock. Only one process will be able to access the lock. There are several processes, right? Several processes want to enter into the critical section. All the processes want to protect the critical section by the lock. First of all, the lock must be accessed. Lock is also a variable. So this variable access should not be provided to more than one process at a time. Only one process will be allowed and use he can use lock at a time. I hope I made it clear. So if a solution is coming from the hardware developer, I'll be more happy since atomicity will be guaranteed. Only one process, either it by myself or it by yourself or by somebody else. Only one cooperative process will be able to access the lock, although more than one process trying to access the lock at the same time. Let us understand. We are working in a multi-processor system. All of we guys are cooperative process. At the very time, we all people entered into different processes. We all people want to enter into the critical section. At that time, we want to access the lock. Even without a gap, without even a single clock cycle gap, we try to access the lock. Now, despite all these events, the lock access will only be given to only one process. That's it. All the other processes will be arbitrarily queued up. Okay, so I will be the guy who can access the lock. Let us say, for an instance, rest of all of you guys who access the lock along with me, who try to access the lock along with me at the same time simultaneously, will not be able to do so. Since it is atomic, this is what atomicity. Now let us recall test and set. So any process which want to enter into the critical section, first of all, it needs to acquire the lock. Right after the lock has been acquired, it can enter into the critical section. Then it can release the lock right after it finishes with the critical section. Test and set lock, simple. As I told you in the previous session, it is very simple lock. This is the function of the test and set lock. We will call it as an instruction. Functions or the methods will be called as an hardware instruction if these are implemented in the hardware. This is an instruction. Totally it can be considered, it can be treated as a single instruction. When an instruction is getting executed, it cannot be preempted. This is the reason why I'll call, despite these are several instructions, as single instruction. This is a single hardware instruction. It will be executed as a single unit. Okay. Now let us see. When I want to use this lock, first of all, within my application, I need to define the lock to false, right? I need to define the lock to false, and the lock type is Boolean. Okay. Then, following up this function, I'll be able to use this lock. This function is very simple. The initial value of the lock will be passed to the target. This target will be passed to a local variable which is called RV. And finally, RV will be returned. So what this function is returning? This function is returning the value of the lock when it is accessed. Let us say initial value of the lock is equal to false. Obviously, false will be passed to the target. Target will be passed to RV. Now, finally, RV is being returned. So false will be returned out of the function if the initial value of the lock is equal to, by the time it is accessed, false. Meanwhile, you can see this instruction, target is equal to true. This function returns false. Meanwhile, this target, which is actually the lock, will be set to true. So by this way, any process which want to enter into the critical section, if it finds that the lock value is equal to false, it will be able to enter into this critical section by making the lock value to true. If the lock value is equal to false, that means that the lock is available. If the lock value is equal to true, that means that the lock is not available. Okay, so what I'll do is, to protect my critical section, I will make a call to this test and set function. Here, I will pass the lock as a parameter to the argument target. Okay, so initial value of the lock, let us say I am the first process. Being the first process, I find that the lock value is equal to false. Obviously, this function will return false. As this function returns false, I will be able to come out of the while loop and enter into the critical section. Okay, let us say any other process right after myself wants to access this lock, will not be able to do so because they will want to enter into the critical section. Rather, bigger pardon, any other process right after I enter into the critical section, any other process want to enter will be caught up at the while loop, since lock has already been set to true in the previous case, right? Got me or not? Yes or no? Any doubt so far? Yes, Chitra, test lock and set if the lock is equal to 0. If the lock is equal to 0, then it will be set to 1. Then one process which finds that the lock value is equal to 0, it will be able to enter into the critical section. Any process will be caught up here. Very good. And hardware solution, of course, is a hardware solution. Yeah. So this is the thing with the test and set lock. And if we are done, is progress ensured with the TSL, sir? No. Very good question. Very good question. Progress meaning progress is ensured, but bounded waiting is not satisfied. Wonderful question, Anu. Knowingly or unknowingly, you just led this class to somewhere, but let me put it this way. At this point, I will confine this discussion to explain about what we call the advantages with the hardware or software locks. Let me tell you. Listening? This test and set lock doesn't satisfy bounded waiting at all. It doesn't satisfy bounded waiting, simple. Why it doesn't satisfy bounded waiting? I will let you know. Let us discuss. With me or not? Of course you are. Stay focused, stay alert, be active. We are not at about to sleep. We are now at the important concept. I want you people to have your well wits and wishes. Let us start. Let us say one process left the critical section. Okay? One process left the critical section. And one more process, when it enters into the CPU, it just is able to execute one while condition. As the while condition satisfies, this very process which is failed to enter into the critical section finally got preempted. Let us understand this. There is PANI while in the critical section got preempted. Okay. Now one more process enters, PCHI. This PCHI is not able to enter into the critical section since it is caught up at the while loop. You can see the infinite loop here. Yes or no? If the condition, the condition gets satisfied, the lock will return 1. As long as the lock returns 1, the while condition gets satisfied. So obviously, PCHI will not be able to do anything other than executing only one instruction all the time throughout its CPU burst. So finally, for no matter, let us say PCHI's time is 30 milliseconds. It is given to spend 30 milliseconds within the CPU. Right after 30 milliseconds, this PCHI needs to leave. Okay, needs to go back to the main memory. But during this time period, it is not able to do anything rather than executing one silly stupid instruction which is the condition within the while loop. Now let us say Mr. PANI re-entered. Okay, this PANI now finishes with the critical section and sets the lock value to false. Okay, now lock value has been set to false, right after which he got preempted. Now PANI also is in the main memory in addition to the other the cooperative processes. Now, do we have any guarantee that PCHI will be scheduled? Who is scheduling? Recall, scheduling is done by not we both. Scheduling is done by a third party who is based on some other parameters. Shortest job first or longest job first or priorities or non-priorities. The scheduler guy decided to schedule me again. Okay, now when PANI goes again, let us say if PCHI gets into the CPU, then it will be able to come out of the while loop since the lock value is equal to false. But it is not scheduled. If it cannot get scheduled, it cannot do anything. Rather than waiting indefinitely within the main memory. Let us say one fine moment PNI has got rescheduled again. Now this guy, very notorious, he wants to re-enter into the critical section. He will be able to do so. Lock is available, right? Yes or no? Lock is still available. Now I just left the lock. I went to the main memory. What I can do? Scheduler decided to schedule me again into the CPU. Again, I can go back to the CPU. Since the lock is available, I can use the lock again. I can enter into the critical section. So this is the very reason, although it is very robust, this test and set lock cannot satisfy the bounded weighting criteria. Bounded weighting criteria, if doesn't get satisfied, of course, it's a huge disadvantage. We can't afford this disadvantage at all. Now, in some other session, I will tell you, I will explain how we can attribute this bounded weighting to test and set lock. Any doubts? So spin lock, yes, spin lock is this is spin lock, right? This while, this busy waiting itself is a spin lock, right? Yes or no? Hi Tushar, very good evening. Spin lock, what you told is exactly correct. When a process has to wait on a lock within a while loop, we'll call it as a busy waiting or a spin lock. It is spinning around the same instruction. Same instruction is getting executed again and again and again and again. Okay, so what we'll do is, can we deny this lock? Is it inappropriate? It is quite appropriate. Being a hardware designer, he is providing you with an excellent lock. Use it. You know how to, being a programmer, you should be able to know how to attribute the feature of bounded weighting by constructing a simple programming module. Although, being a hardware lock, it doesn't satisfy bounded weighting, but you are a very good programmer, right? Can't you write a simple module of code where the lock can satisfy the bounded weighting? We can do it. So, if the lock is available, please take it. Use it. And use it in such a way that additional modules are written to have this lock satisfying bounded weighting. Simple. Got the point? So I will tell you in some session, I will dedicate for attributing bounded weighting to the test and set lock. One session I'll specifically take. For that, we need to discuss about the logic because we are writing a program. So what we'll do is, in a separate session, I will explain how the bounded weighting can be attributed with how test and set lock can be attributed by a bounded weighting by the programmer's approach. Okay. This is how the lock works. Okay. Now, one more hardware solution is a compare and swap instruction, which is also similar to test and set lock. But compare and swap, of course, uses a different lock. This not completely different. Here, I'm going to use an integer lock. If it is an integer lock, I need to initialize to 0, right? If you use compare and swap, what you need to do is, you need to initialize a lock which is of a type integer that is initialized to 0. Then the compare and swap is also very simple. Okay. Now the thing is, this is the definition of the compare and swap. Here, there are 3 parameters. One is star value, which is the actual value of the lock. And one is int expected. One more is int new value. This int compare and swap will have 3 parameters inside. One is the lock, a reference to the lock. Second one is expected, and the third one is new value. Here also the same thing. The initial value of the lock when it is accessed will be transferred to a temporary variable, a local variable. Finally, this temporary variable will be returned out of the function. So initial value of the lock, if it is 0, the function returns 0. If it is 1, function returns 1. Meanwhile, what will happen is, if the value is expected, the value will be updated to new value. Is that making some sense or not? Once again, let us have a look at this compare and swap. Compare and swap, int compare and swap function has 3 parameters. One is the value which is a reference to the lock. Second one is int expected, int new value. Here itself I will tell you, expected can be 0 and new value can be equal to 1. Simply, this total function states that obviously initial value of the lock will be passed to a temporary variable. Okay, if the lock value is equal to 0, this temp will be equal to 0. Finally, the function returns temp, which is the local variable. Temp returns 0. Now, this if condition checks if the lock is equal to expected. What is expected? 0. Then the lock value is equal to new value. That means that if the lock is equal to 0, then the lock will be equal to 1. I hope I made it myself clear. These 2 statements make sure that if the lock value is equal to 0, then the lock value will be set to 1. Yes or no? Did I make it myself clear? Sir, in the critical section, Well, cache, a black cache, I mean, this is completely, irrelevant right now. I just, when I get into those topics, there's a lot of time get wasted. Just shoot your doubts in my Telegram channel. I will address those doubts personally. Anything? This is what? How the compare and swap works. You want me to re-explain this? I will do it. Simple. When you want to enter into the critical section being a process, you should be able to make a call. Before any process wants to make an entry to the critical section, initially it needs to make a call in the while loop. Okay, it needs to check the availability. That is, if the compare and swap lock, 0, 1 is not equal to 0, that means that it will be in the while loop. What compare and swap? Lock is equal to, let us say, initial value of the lock is equal to 0. Okay, then obviously the function will return 0. Obviously this condition fails. Compare and swap ampersand lock, 0, 1. If this function doesn't return 0, then you will be in the while loop. If it returns 0, obviously that means that the lock is available. After setting this lock to 1, you will be able to enter into the critical section. Right? Right after which, while coming out, as in the test run set lock, you need to make sure that you release the lock. Similarly, here also, bounded waiting cannot get satisfied at all. Yes or no? Always return temp means always, is it sensible? Let us understand. Okay, I will explain. I will explain. Mr. A.B. de Villiers, ABD, enter into the critical section. Mr. ABD enter into the critical section. When he enters into the critical section, when he checks this lock, that time only this while loop returns a 0 value. Right after which, what will happen? Lock will become 1, right? Let us have a look at. See, when you make a call, before you enter into the critical section, you need to call this, right? When you make a call, obviously lock value is equal to 0. Okay, that value is passed to temp. This temp returns 0. Meanwhile, what is happening? You are setting this lock to 1. Only for the first process, the function returns 0. From the next process onwards, as long as when process is already in the critical section, the lock value will be equal to 1, right? Did you forget to look at this code or what? Yes or no? This is when what do you call, a process is already in the critical section, what will be the lock value? Only for that process, it is equal to 0. Temporary initial value of the lock will be passed to temp. Lock is equal to 0, temp is equal to 0. Okay, finally, temp value will be returned out of the function. Meanwhile, what is happening? This expected, if the star value is equal to expected, if the value is equal to 0, then the value will be equal to 1. Right after the execution of the function, the lock has got a new value. It throws the old value, but lock gets a new value which is equal to 1. Okay, only for the first process, the lock value is equal to 0. The function returns 0. I hope I made it myself clear. Yes or no? ABD? Got me or not? Yes. I hope you got it. Any doubts? You can shoot it here itself. Now the thing is, can I go to Mutex locks? We discussed about test and set lock and compare and swap. Now it is the right time to enter into the Mutex locks. If you do have no doubts, I will enter into the Mutex locks. Very good. Let us understand. Sir, fine. You told that the locks are very robust. Hardware locks are superb. We will use only those locks. Why do we need to discuss about any other thing? We just need to use the same locks, right? But let me tell you. What is the example that I have taken? Chitra is the hardware developer and we guys are the software developers. Let us say that processor in which the lock is available is i3. But now understand the problem is, unless you listen to this precisely, there will be some chaos. Understand the statements, understand what I am explaining here. There is no guarantee that your application will run on only one processor. Your application is processor independent, right? let us say in one specific processor, that is i3, provide you with a lock. But do you have any guarantee that when you develop an application, always it is going to run on i3? No, whenever we develop an application, the application is processor independent, but every application is operating system dependent. Because when you develop an application, you're going to keep your application design the application in the aspect of an operating system. You're going to develop any application by using an API. Let us discuss about APIs. What are the different APIs? When you want to develop an application, you need to design an application in 3 APIs. Windows API, let me tell you. Java API, or what do you call, there is some other API, I forgot it. What is it? POSIX API, yes. Now, when you develop an application by using a Windows API, your application will run on all the Windows systems. Java API, your application can run on any system that is implemented with a Java virtual machine. When you develop an application by using a POSIX API, your application can run on any Linux versions, operating systems, as well as some of Mac versions also will work. When you develop an application by using a POSIX API, your application can run on some Mac systems and some Linux systems, all the Linux and Unix systems. When you develop an application by using a Java API, your application will run on all the Java machines in which Java virtual machine is implemented. Windows, obviously your application will run on any Windows machines. But our application is not designed keeping the aspect of a processor. Our application may run in any processor. So it is the very reason why we don't use the locks, since we don't know whether our application is running on i3 or Snapdragon. What if Snapdragon doesn't provide you with a lock, but you protect your critical section feeling that in particular process in which my application is running, there may be an availability of lock. You can't pretend the things. You can't imagine the things. All of the processor may not provide you the lock. At that time, what may happen, your call for the lock will lead to a null value. There is nothing as such a lock in the hardware, but still you protect your critical section by using hardware lock. What will happen? When you call a null function which is not existing, your program will get terminated. Got me? So I'm not getting you people into those details. Simple. The thing is, we don't know on which processor our application is running, so we can't use the locks. It is inaccessible. So what we do is, we can use a software locks. Software locks meaning, these Mutex locks are being provided by the operating system developers. Obviously, we know on which operating system our application runs. If you do have every guarantee that in some operating system there is an availability of the lock, you are free to use it. Got my point or not? Yes, it is architectural neutral. It must be architectural neutral. Wonderful. Okay. Now, these Mutex locks are provided to application program developers simply because the hardware locks are inaccessible. But let me tell you, at this point of period, standing here, I can assert and admit something very firmly. All the processors nowadays are providing you with the locks. All the operating systems nowadays are providing you with the locks. Since we are at 2022, obviously, all the, it could be Snapdragon or it could be i3, i9, all the hardware developers are providing you with the locks inside. All the operating systems, every advanced version of the operating system, including Windows and Linux, providing you guys with the locks. Okay, so let us enter. Anyhow, the problems are problems. We need to discuss about this. Mutex locks are being provided by what you call the software developers. TSL is complicated. We don't use. OS designers build software tools to solve the critical section problem. Simplest is the Mutex lock. Here the simple. We need to access a lock from operating system. The operating system is now giving you a lock. Okay. Now the difference between the hardware lock and the operating system's lock is, if the hardware lock, stay focused, if the hardware lock is false, then that means that the lock is available. Here in this case, the scenario is slightly different. What is the scenario? Let us understand. All these are not necessary, but still, protect critical section by using acquire and a release lock. If you want to protect a critical section, you should execute two functions. One is acquire and one more is release. Okay. If a process PI successfully executes acquire function, it will be able to enter into the critical section. Every other process obviously will not be successful in executing the acquire function since the lock is not available. How it exactly is going to happen? Let us understand. The acquire function is implemented in this way. As I told you, the lock is named as available. The available should be initially equal to true. If the lock value is equal to true, what is lock? Lock is available here. I renamed it as available to make the thing simple and to keep the discussion fairly simple, I am using a name available. If the available is equal to true, that means that the lock is available. If the available is equal to false, then that means that lock is not available. So the thing is, this is the acquire function. While available is equal to false, that means that when the lock is not available, the process will be caught in the while loop. When the available is equal to true, it will be able to come out. Right after making this available to false, it needs to enter into the critical section. Making sense or not? Yes or no? Software lock is initially set to 1, as simple as that. Very good. Why Mutex? I will tell you. Hold your horses. I will explain you why Mutex. Mutex lock is a operating system solution. As an operating system solution, it is accessible by the application program developers. But since Mutex locks also have their disadvantages, we are going to discuss those disadvantages right now. Again, I need to enter into the critical section. Before which, I need to check if the availability, I need to check with the availability of the lock. Once again, if the available equal to false, available equals to true, that means that lock is available. So let us see the first process which want to enter into the critical section. While it is executing the acquire function, it found that the available is equal to true. Immediately, this condition within the while loop will fail. So coming out of the while loop, it will set the available to false. Okay. And will be able to enter into the critical section. Right after which, any process which want to enter into the critical section, when executing this acquire function, will be caught in the while loop since the available is already equal to false. So any other process will be caught in the while loop until and unless the current process comes out of the critical section and executes the release function. In the release function, in the release method, it needs to set the available to true. As simple as this. So right after current process executes available equal to true, then any process which is actually waiting at the while loop, which is caught at the while loop, can get released and enter into the critical section after making the available to false once again. So this is what you call a software solution, an operating system solution. Only by considering the slightest difference, both hardware solution and software solution works on the premise of the locks. Locks are defined in the very similar way, pretty similar way, right? But only the problem is, either you go for a hardware solution or you go for a software solution. The biggest disadvantage is the spin lock. Somebody stated, raise your hand. What is spin lock? Hello Pooja. Hello, Gaurav. Tell me, what is spin lock? Oh, thank you so much. And Chitra, where are you guys? Are you listening or not? Fine. What is spin lock? I will tell you what is spin lock. When a process gets caught up at the while loop, it won't be able to execute anything at all. What is an infinite loop? The same instruction will be executed again, right? So this is going to kill a lot of CPU's clock cycles. For an instance, P1 is in the critical section. One more process, let us say Pooja enter into the critical section. Pooja want to enter into the critical section. She may not be able to do so since she will get caught up at the while loop. I will explain you how many CPU's clock cycles will get wasted. There is, listen carefully, stay focused and understand. There is a CPU, and of course there will be a CPU. There comes a process, that is PX. PX is executing in the critical section. But obviously, PX will be preempted sooner or later before it finishes with the critical section. PX preempted and went back to the main memory. Meanwhile, what happened? PY entered into the CPU. Now PY, when it wants to enter into the critical section, it may not be able to do so since it will get caught up at the while loop. Let us say PY's total time, allotted time is 30 clock cycles. For the total 30 clock cycles, PY will only execute one and only one simple instruction, that is available is equal to false, available is equal to false all the time. So it won't be able to execute any productive instruction. Total 30 clock cycles are simply wasted. Right after the 30th clock cycle, it will be sent out. Mr. PY, you are done with your execution. Please get out. So PY also has come here. Let us say PZ, which is fortunately, unfortunately, one more critical process, one more cooperative process enters into the CPU. It also wants to enter into the critical section. For this also, the scenario will be no different. It also needs to execute the condition within the while loop. As the condition gets satisfied, let us say this PZ, right? This PZ total time period is 40 clock cycles. 40 clock cycles are wasted. No matter for how many times this PZ and PY get scheduled within the CPU, as long as PX did not finish it with the critical section, total number of clock cycles will completely be wasted. No more, it is not productive. CPU's clock cycles are being completely wasted without executing a single productive instruction. Now we are talking about only 3 processes. There can be 100 cooperative processes where one is executing, another one, all the other ones are actually waiting and spinning at the lock. This is called a busy waiting. Busy waiting imposes a lot of practical restrictions. CPU time is not being productively utilized. After all, for what we are working, we are starving for throughput. We are starving for executing more number of instructions within less time. Now, these constraints will reduce the performance, will reduce the number of instructions, will reduce the throughput, right? So this is exactly the perspective to understand the spin lock, busy waiting. It is not simply, knowing a term. We need to dive into the details. What exactly is happening? Now tell me, is it a complicated one? No. Only it's like, it's in our minds. There is nothing complicated. In one of the sessions I told you, there is nothing complicated ever. Okay. Only thing is the way we look at the things will actually define. You got me? Okay. So we are going to understand about a robust tool in which busy waiting can also be avoided, which is called a semaphore. But not in this session. In the tomorrow session, I'm going to introduce people with the semaphores. That's it from the session. Aneel Prasad Sir is about to sign off. But before that, I want you people to shoot any doubts if you do have so far in this session. Any doubts? Like and share this session and subscribe to this channel if you haven't already yet. So that's it from the session. Aneel Prasad Sir signing off. Good night.